Okay, so let's keep talking about our Unity stuff. I do want to introduce, let me pop Unity open here to see if we so is this finished updating yet? It did finally show me that update, but whatever. I'm not going to mess with it too much right now because I was downloading it earlier. That's Unity. Here's the. Yeah, it finished it. So maybe just for simplicity's sake, let me just reopen that project in case the editor needs to reopen, because this should now match what everybody got. All of you have the .31, I think is the latest greatest one. I think I was on what 29 or something from last semester. Some small bug fix, but just in case something weird happens. Okay. Okay, so last time I'm in the wrong one because I created a second project, didn't I? Oh, maybe I deleted the sphere at the end, so it's fine, or the cube. Okay, so we saw last time I went up into this area and I added some things to our scene. So I threw a cube in here and it throws it here at 0, 0. We talked about the idea of a generic game object. Let me put up Keynote here. Okay, so we talked about this idea of a generic game object. We can really think about this as something very similar to how the generic object works in Java, right? This is the most basic thing that can live inside of our Unity project is this thing called the game object. And we talked about the basics of that, where a game object itself, let me minimize that, basically comes with a transform. If we create oh, that's right, I originally had dumped in a empty game object. That's why I had done. So if I add an empty game object to this, not a cube, but an empty game object, all that guy has associated with it over here on the right in this inspector is this idea of a transform. And a transform says, where is it? How is it rotated? And what's its scale? And we get an X, Y, Z on all of those things. All right. So now when I throw in the idea of a cube instead of a generic game object, we get a couple of other things hanging off that game object. So now we get a cube mesh filter. We get a mesh renderer. This is how we can see stuff. We have a box collider. This lets it bump into things, and we'll maybe look at that some today. And then we get this default material, which makes it look white in this case. Hide floating meeting controls. There we go. All right, so if I hit play right now, we're going to see the box just sitting there in the middle of the screen. And the reason we see that, I know we looked at this last time, I'm just kind of reviewing that real quick, is it placed it at 0, 0. We already have a camera here in the scene called the main camera. And if you click on the camera, you see what its view will be down here. It kind of shows you, oh, that box will be right there. And if I go in and grab that cube and I move it some, you could actually grab it, the cube itself, or you can drag on these arrows to kind of keep it in a certain line. So if I kind of move it off center a little bit there and I click on main camera, now we see it's not centered anymore. So you can kind of quickly see what the camera is doing. A good way of also looking at the whole scene, if I click on sample scene here, is looking down. So right now I clicked on the y-axis, so I'm looking straight down on the scene, so I can see where the camera is relative to my light, relative to where the cube is, and I see, oh, the cube's a little bit off center, so I can drag it back over there and get it roughly into the center. I can then come up here and directly edit it and make it actually at the center, 0, 0, 0. Okay, so it does take a little bit of practice to get used to how to manipulate the 3D world, and the more stuff we kind of get in here, the more weird it maybe gets. And we'll see how it kind of works out with the touchpad thing here. That's going to make it a little bit funky, maybe in some cases, but it shouldn't be a major deal. All right, so let me get rid of game object here. Just delete this guy. Okay. So we have our cube in here. So by default, the cube has this box collider and stuff. Now, I think last time I said, let's add a component, and one of the things that a game engine does is it says, I'm going to do all the physics math for you. It does all the special sauce for that. So if we go under the component category, after we click add components and we go to physics, one of the things we get in here is something called a rigid body. So rigid bodies are something that's we're gonna use all the time in our Unity games. It's what gives our things mass. So if I hang a component off of this guy, so I'm just adding features to this game object, I'm adding a rigid body. This guy by default has a mass of 1. Then it has some other things that how it interacts with other game objects. And by default, use gravity is checked here. So right off the bat now, the scene that we're in, just as we can think of it as an empty room like this, gravity exists in here. And now I have something that has mass. Something without mass is going to float. Gravity's not going to have any impact on it. But now that I've given this guy mass by attaching a rigid body to it, since this scene we're in has gravity and this guy participates in gravity, he's now going to fall out of the sky. Gravity is making him drop. Okay. If I turn off and I say, hey, you no longer participate in gravity just because, you still have mass, because that might come in handy later on when you interact with other game objects, but I don't want you to participate in gravity anymore. Now it'll still just hang there. But now it technically has mass, even though from our perspective, nothing's changed. Okay, so now what I'm going to do, I'm going to go ahead and double click on this box script thing. I think we created this last time. Open it up in Visual Studio. All right, so we have this thing called update, and once per frame, update does something. Now I'm going to go and actually steal. I just want to steal some code from this guy, and I'll just talk through it. Okay, so we created this script in our assets. So again, this is just our collection of assets down here, and I made a folder called scripts inside of my collection of assets. And doesn't really matter, but I put the script inside there. And at this point, this is just some code. It's not attached to game objects or anything like that. This is just, right now I have a scene that has some game objects in it. Each one of those game objects has this inspector thing that lets me change stuff related to that game object. And now I'm writing some code. None of these guys know how to play with each other yet. All right, they're not connected. So in this box script, the idea is that I'm going to be attaching this script. In a few minutes, we're going to be attaching it to our cube. I'm going to be attaching this script to our cube, so it's going to become a component of the cube, just like the cube has a rigid body, just like the code has the cube has a renderer, all those things. All right, so we're going to have a box script. It's going to be something called a mono behavior, which is the default scripting behavior for for Unity. Not everything we write will be a mono behavior. We'll pretty soon start writing our own objects, just like we did in Java, where we don't actually intend for those guys to govern the movement or something of a game object. Instead, we want it to have programmatic stuff. We want to be able to represent a room or a player, or things like that, and create instances of those guys. All right, so what I'm doing here is I'm creating a couple of variables at the top, and kind of the idea here of this script is we want our, when we turn gravity on, so by default, the cube is just going to drop, right? So we want this script to allow our cube to go upwards automatically. All right, so what I'm going to do is I create a vector 3. So a vector 3 is just a X, Y, and Z. And a vector 3 can represent, we can see examples of vector 3s right here. If I click on my cube game object and we go over to this transform, position is represented as a vector 3, X, Y, and Z. Rotation is represented using a vector 3, X, Y, and Z. Scale is represented using a vector 3, X, Y, and Z. Okay, so vector 3s are effectively a collection of 3 values. That's all it is. All right, and then I'm just choosing a speed that I want my cube to move at, something like that. And you could make that whatever you want. This is just, I played around with the number. This seemed reasonable enough. Okay, now I had mentioned that this function start gets called at the very beginning of your code. So this guy gets called one time before the first frame updates. So this would sort of be like a constructor. Okay, we could think of that like a constructor. It gets called one time and it kind of initializes things. So we could make the argument here that we actually want to set the value of go up here and the value of speed in here. And then maybe we just define the variables up there. So now it sort of kind of looks like our normal objects where we have our fields at the top. Then we have our constructor that initializes some of those things. All right, so this isn't exactly a constructor because this really is more of a timing thing. Start says, do this stuff before the object this is attached to goes and does anything. Do it once. Update says do all this stuff every frame. So as a game is running, it's running so many frames per second, and that's driven by the quality of a graphics card, that kind of thing. So if we assume that this is running at 80 frames a second, let's say, this function will get called 80 times every 1 second. So whatever happens in here will happen 80 times in a second. All right, so what are we doing every fraction of a second here inside of update? Well, I'm going to go ahead and in this case, just like in Java, the this keyword is how an object refers to itself from within itself. So in here, this is the game object that this script is attached to. That's what this is. So we're going to hang this guy on a game object. We can actually go ahead and do that. So I'll click on my cube. I'll click on add component. The type of component I'm going to add is scripts. And I have one script that I've written here called box script. So I connected my box script to that guy. We actually already see it previewing there. In fact, actually, wasn't it still running? I mentioned this last time. Be careful. Whenever you do something when the game is running, it gets undone when you stop it. Notice my component's now gone. So it allows you to kind of test stuff without making it permanent. But now I need to go and put it back in. So I stopped running here. I'll click add component, go back to scripts, go to my box script. So now it's in there. All right. And we don't need to really worry about what's here inside of our box script right now. We're going to change something here in a minute. Okay. So now let's go back to our script. So now I've connected this script to my actual game object. Inside of this class, this keyword represents the game object that this script is attached to. Now you could have the same script attached to 20 different game objects if you want to. And for each instance of that game object, this will be the instance of the game object that the script is attached to. Very similar to what we're dealing with in Java. But now we kind of have this physical thing that we're seeing kind of on the screen doing stuff. All right. So if this is the game object that's attached to this, and we see game objects are effectively a collection of components. That's what a game object appears to be. If we go in here to our game object is a collection of components. When we want to deal with a specific component of our game object, we have to kind of extract that component from it. We have to ask our game object, give me the rigid body, your rigid body component, because I want to do something with that. So back here in the script, I'm saying this game object. Do that later. I want to get a component. The component I want to get is the one that's of type rigid body. We've seen this syntax before when we were using array lists. So this is a generic. So I'm not getting a generic component. I want to get the component of type rigid body. And that's going to boil down from here and give me, inside of a variable called RB that I created here, the rigid body portion of this game object. And then I'm going to go ahead and set that rigid body's velocity. So a rigid body, if we go in here and we say Unity rigid body. Here's the documentation for this guy. Let me make this a little bit bigger. So here's the properties of this, and one of the properties is called velocity. So this is the velocity vector of the rigid body. It represents the rate of change of the rigid body's position. We can also turn gravity on and off just haphazardly. We can just decide, oh, gravity's off for you now. So these are all, we can change the rotation, we can change its position. We can change this is kinematic, whether or not physics affects this rigid body. You know, if it starts bumping into other things, do we want all that physics engine stuff to happen so it makes it look like real things are occurring? So all sorts of different things that we can do with this guy. They also have public methods. So if you think about this like our objects, so again, this is like reading our documentation for Java. We have a bunch of fields or properties that we can manipulate for an instance of rigid body. Then we have a whole bunch of functions that we can call associated with a rigid body. I can add torque, I can add force, I can ask if it's sleeping, I can move its position, I can move its position towards a position. So maybe you have a game where it's like, you know, somebody has, I don't know, like think like Mortal Kombat with like Scorpion, where he throws the thing, is like, get over here. You know, you can do that and have it fly towards a particular position. So the idea is it has a bunch of stuff built in to it. We have an ability to send messages to other things. We'll play with that stuff. And then we get a whole bunch of inherited properties from the generic game object. One thing you will see here is there seems to be a kind of a weird relationship between this keyword and the game object that it's attached to. And it's because components are also implemented as game objects. So if a rigid body is a game object and a game object might have a component that is a rigid body, we technically could say this .game object .game object. And that's still a thing. So this is the game object. I want that game object is the game object that this is associated with. Then you get the rigid body and you say dot game object. That's still the original game object. So it gets a little bit of a weird situation there, and we'll see some examples of that. Tag, all game objects can have a tag. That's kind of a almost like a variable name you might use to represent something in your game, although tags are not necessarily unique. You can say that maybe you're creating some sort of video game that has a bunch of monsters on the screen, and anything that is a monster you might tag as monster. Okay, so you might want to do something to everything in your game that is tagged monster, and you can make something like that happen. And that kind of goes along with the message passing stuff that we'll see here, because we can broadcast messages and have everything listening for things, messages that are being sent out. And we'll see those things by example as we get in here. Okay. But in any case, one of the properties of a rigid body is its velocity. And what I want to do is I want to set this rigid body's velocity, that property, I want to set it equal to go up, which is a direction up. This is 0 on the X, 1 on the Y, 0 on the F, up. Okay, on the Y axis. So I want to go up at this speed. Okay, so every single frame, and I'm using the example here, let's say this is happening 80 times per second, because using update as opposed to, there's another function called fixed update. Fixed update says this happens 60 times a second to kind of standardize it. Update says, hey, I'm going to get called as often as frames are rendered. For our simple little game here with any sort of modern computer, probably faster than 60 times in a second. But every time a frame is rendered, we're going to update this rigid body's velocity from whatever it currently is to a upwards trajectory at a current speed. Make sense? All right. So that's all this script does. The script sets up a couple of variables, and then this guy right here is what drives the script. You can almost think about this as like our run method for our threads. You know, just sitting there in an infinite loop. It says do this over and over and over and over and over again. Anything that this script is attached to does this forever. So we go back in here to Unity. We have our cube. We've attached this boxed script to the to the cubes. Now those two guys are married together. I hit play, and every single frame, we're updating the velocity of that guy, and it's pushing up against gravity. Now, if I turn gravity off for this guy, well, actually, gravity is already off for him. So we'll actually see if we overcome gravity with this guy. You see how it's almost like hiccuping? Because it's being forced down at the same time as we're pushing velocity up. So if we slowed that speed down enough, we could probably get it to hover or something like that. It's doing the physics math for us. Similarly, if we up the mass to 10, I think the way this will end up working is it'll make gravity impact it more. Did not appear to be the case. I'm not going to mess with that right now. Oh, that's not going to update. All right, so now I want to talk about something called MVC. First of all, I want to talk about something called a design pattern. All right. Now, I don't think we've never mentioned design patterns in here or in 200, have we? First time you're hearing that? All right. So a design pattern is a generic term that we use I mean, it's something that we apply to all sorts of different things. And I'll give you an example here in a second, but a design pattern is a proposed, quote, good solution to a, quote, common problem. Okay. Where good can mean all sorts of different things, and a common problem to one person might not be a common problem to another person, right? You work for Lockheed Martin, a common problem might be fuel efficiency with jet engines or something like that, where that's probably not something that comes up real often for us in our daily basis. Maybe a common problem for us might be how to make a good peanut butter and jelly sandwich, right? What's the right solution? You put the peanut butter on first and then the jelly and you smash it together. How do you do it? What's the right way to do it so you don't rip the bread and all that jazz? So you can have your own little approach to something like that you think is the best. You usually design patterns, if we think about what they typically have a funky name. So some examples of that, things that we're going to look at are singleton, MVC, just leave it like that. There's a whole bunch of things. An interesting kind of thing that, and I might almost say it's a problem with design patterns, is in academia, we have this idea of publish or perish. So, as academics, we're supposed to do research and add to the body of work that makes up, in our case here, computer science. So what that typically, and doing research doesn't necessarily mean doing something that improves the world we live in. It could just mean that, oh, we tried this and it doesn't work. So we're letting you know that. We're advancing the body of knowledge about something, right? Okay. So from an academic's perspective, they can write research papers. They can make up an idea that says, oh, I think XYZ is a good approach to this problem. That's my theory. Then you go through and you write some simulations, you test it, and in the end you conclude this is not a good approach. I encourage future people to not do this. I've done the work for you. I've already failed. Don't do this thing. So then what you end up having is you go and look up in various research journals. When you look at the publications, you'll find a whole bunch of design patterns in there that all have funky names, because it's really easy to get approved for a design pattern, even if it fails, even if we say, because usually it's not going to fail in terms of does it work. It's going to fail in terms of this isn't any better than other approaches. Or this is actually a little worse than other approaches, but hey, we tried and now you don't have to try. So I think academics kind of take advantage of the idea of a design pattern in general. But every now and then, certain design patterns kind of bubble to the top as being good ones. So one of the things that we're going to look at in here is something called MVC. This is the model view controller, design pattern. Now, one thing to keep in mind with design patterns is these guys are not implementations. Design patterns are concepts that you would then implement in a certain way. So MVC says it's a good idea to keep your logic, interface, and data in separate places, and then have a way for them to connect somehow. All right. So MVC doesn't necessarily dictate how that connection must occur. It just says, you know what, you probably shouldn't have all your stuff inside of one giant file. And if you go back in time a little bit and look at some like web development, one of our popular web development languages still today is a language called PHP. And PHP was, I would say, probably our first real programming language designed specifically for web pages. And the problem with that is when it came out, our web pages were still pretty simple. But now our web pages have gotten more and more complex. You go to MSN or any of these portals, you got a whole bunch of stuff on the screen. You know, if you go to my.cuw.edu, you get a whole bunch of stuff on the screen. Well, the idea would be if you were doing this in original PHP, inside of your, homepage.php document, you would have all the logic that makes that page work. You'd have JavaScript that, oh, you click this button, this happens, you do this, this happens. But you would also have all your interface design stuff living in there as well. And what you'd have is you have this special little syntax that lets you embed PHP code within your interface. So you'd have basically an HTML document with all the interface of how your site's supposed to look, with just randomly embedded PHP throughout there using these little these tags that allowed you to include scripts. Now, as your web page got more and more complex, you might have a 50-page PHP file that was just this intermingling of your interface and your logic. Very hard to maintain, very hard to debug, yada, yada, yada. We came up with some ways of getting those guys separated. Effectively, this idea of MVC grew out of that problem. The computer itself doesn't care. The computer itself is going to be able to keep track of what stuff is interface stuff and what stuff is logic stuff and where does your data live. But from a human being perspective, we're going to get lost pretty quickly. So most of our modern day development tools, especially things like Unity, Android Studio, Xcode for making iOS applications, Visual Studio for making Windows-based applications, or even web applications. Visual Studio has a tool called ASP.NET where you can generate web-based stuff. It has components for, one screen is your interface builder, another screen is your code, and then it usually has a way of linking to a database somewhere. And then it gives you interesting ways of making those guys all talk to each other when you need them to talk to each other. But if you're going to make tweaks to the interface, you go to the little application for working with interfaces only. That's what we're looking at right here. This is interfacey stuff. Okay, we're designing what our screen looks like. If we need to update the code that's involved with this guy, we go over here to our Visual Studio. Now we're messing with our logic stuff. Right now, we're not talking to a database. We're not pulling data from anywhere. So we really don't have that component. But if we did, we'd want that to be in even another place, at the very least a text file or something like that, living in a separate place. All right, but now we need these guys to be able to talk to each other. So down here on my cube, I have my box script component attached to this guy, and inside of the box script, I went ahead and I have a field called float. If I make this guy public and then save it, it was a field of type float called speed. If I make it public and then save it, notice here that now I have a variable in here that allows me to type in the speed. Okay, now if I type in 50 right here for my cube, for my speed, and then I hit play, we see it elevating at the exact same speed as it happened before. Why is that? Over here, as soon as the first frame hits, what do? I overwrite speed with whatever you set it to, 50 with a 2. So it didn't matter that I put a 50 in there. It became a 2 programmatically. If I go up here and I set it back to a 2, and I don't update it down in here, All right, so I defaulted it to 2 inside my code, but I currently have it at a 0 here. So what's happening? Gravity's pushing it down. I could probably update this in real time. If I switch it to a 2, now it's going up. If I switch it to a 5, it goes up faster. -4, it's going to start to drop again. So I'm yo-yoing it here just by changing that speed variable. So what I'm doing here is I am exposing one of my programmatic properties, one of my programmatic fields to my interface so that I can dial in my script here. You can write the script generically. So now what I can do is I can have, so let's say I have this cube, and I'm going to have this guy going at a speed of 1.5. Let's see, can I just duplicate this guy? I'll duplicate this cube. And I'll scooch this one over a little bit. All right, so I have 2 different cubes that both have the same components in it. And I'm going to change my second cube's speed to a 4. Now, when I run this, we're going to see one of those guys go up faster than the other one. Even though they're both running the exact same script, I've dialed in the value for those 2 scripts differently. Make some sense? All right. Similarly, I can come into my code here and I can make my go up vector. I can make that public. Okay, come back over here. Now I see I have even another variable. Now, not only do I have speed, now I have my X, Y, and Z vector. So I can make one of the guys, I can make him go straight up. And I can make the other guy go to the right. Okay. Notice that guy's kind of arcing down because gravity's still pushing him down. He's not pushing up against gravity. Okay. But I now made my interface become aware of the generic aspect of my logic, but gives me the ability to dial in things. If I want to go up and over, I would do that. So now it's going on the X and the Y. So it's flying at a 45-degree angle, doing stuff. All right, make some sense? Okay. So now what we're going to do is let's go ahead and I'm going to add another 3D object. Here, we'll just make another cube. And what I'm going to do is I'm going to stretch this guy out. Oh. All right. So this guy is going to kind of be my floor. Okay. And he has a box collider on him. I'm going to go up to my 2 cubes and I'm going to just turn off their script for right now. So I just unhit the checkbox next to the script. All right, these guys are both still rigid bodies. They both still use gravity. All right, so let's see if they didn't start high enough above that guy, I don't think. Well, doesn't matter. We saw it fall through it, right? So if I then come to this guy and I add a rigid body to him, so my floor here, we're going to call this our floor. So I can even name it up here. This is our floor. I need to zoom out. It's just one of those things where having the keyboard or the normal mouse may be a little bit better. There we go. All right, so now I'm zooming out. I'll just move this guy down a little bit more. And maybe move those two guys up a little bit more. All right, well, now they both fell out of the sky because I forgot to turn off gravity on my floor. Okay, so at this point, my floor and both of these boxes have a rigid body with gravity turned on, so they're both just falling out of the sky. Well, I want to go ahead and make my floor be a rigid body, but not have gravity. All right, so now that guy's not falling, but the other guys are falling. If I click on my cube, I see these guys are still going down. So I'm going to go ahead. You're right. It's going to be flat right now. That's what you're asking, right? It's too thin. Yeah, we are looking down from the top. Right. It's thin, but it is hitting it. Yeah, they're right in line with each other. They're both the same width. If it makes you feel better with it, we can make the Z a 10, a 20, something like that. And then we need the actually it is missing it, you're right. So we're going to make the floors wide. Let's make it 50 by 50. So that should look above or below. See what we're looking at here. No. Well, I'll get us centered better. We're out of time. But so what we're going to do here is we're going to have these guys drop and hit the floor and have the floor stop them. Okay. And what's governing that is the idea of this box collider. So box colliders in conjunction with rigid bodies that have physics associated with them can interact with each other and they keep each other from going somewhere. So we have the floor with gravity turned off. We have the rigid body dropping. And if we drop something and it hits the floor stops it, right? And if we want it to do some bouncing, we turn on kinematics and now things might do some bouncing. All right, questions about any of that? So maybe mess with this a little bit. It does take a little bit of practice to kind of get used to using the interface here to get things working. I have historically found that using a normal keyboard, so see how I'm moving it here, if you hit the right mouse key and hold it and then kind of move it around, you can create the angles that you might want to see stuff. But using a trackpad is a little bit funky to pull that off. But maybe mess around with that and see what you come up with. But we'll come back next time and look at our rigid bodies interacting. And we're also going to then add keyboard controls so we can kind of drive our cube around and stuff like that, and then start building some gameplay stuff out of it and get our objects coming in. All right, I'll see everybody on Friday. Yep. Are you doing it, is yours in Visual Studio or VS Code? You have the same stuff up here? Should have included this stuff by default. It sounds to me the reason it's not coming out. I mean, are you getting an error here, or when you run it, is it giving an error?
I'm not getting any errors here. When I run it, it's like, oh, fix compile it, and when I go back to
Does it tell you what the error is?
No, it'll pop up. It says no issue.
A lot of times the errors will show up down here in red.
I'll look at it. Yeah,
Okay. Oh, I see. I see. Yeah, the errors will come up in red. I'm guessing maybe a semicolon or something like that.
It didn't tell me like in here, like I would save it in the bottom left of this screen. It was like, oh, no error was found or whatever. But then I go back to the thing that goes
Oh, yeah. See, that gave me an error. So semicolon would highlight something. Other thing, make sure you do is make sure you save.
Yeah.
Yeah, if you don't save it, sometimes it won't update on the other side. So. Yeah, it should be 000. Well, right now I have my box script turned off. Yeah, if I have it set to 000, it doesn't matter what the speed is. So I need to go to my game. Oh, no, wrong thing. There we go. Zoom out. I can. I'll have to. We'll look at it next time. I'll got to create an asset that has a material so I can change the material. So yeah, I can do that. Move my camera back some. Yeah, I think this is the floor that's staying there that has the 000. This is the cube that's just hanging there. The 000. If I change this to a 1, is that not the one? Just take the, we stop this. You can disable game objects by just clicking on them like that. It is. It's way easier. I might have to start bringing one. Yeah. So this guy cube 1 currently is at 000. So this is just gravity pushing down on it. Even though the speed is a 4, it's gonna. We're not adding anything to it. Correct. I actually think the initial values will be all 0 anyways. So unless I give it a value up here. So, well, I would have actually expected speed to be a 2 by default. So if I go to floor here and I say add component and I add a script, box script, yeah, the default is a 2. Only because we've changed it, is our change is sticking.
Right.